Okay, so we can continue to problem number 2 now. I am able to minimize this stuff. Mm, Let me get set up here. By closing problem number 1. So problem number 2 is a little bit different, right? We don't have our parts included or given to us, so we have to create them. So for the first part of this problem, let's create the necessary components, and then we can add them into a mate. So we do need to create the block, the slider, and the pin, or the clamp in this case. So we'll go and create a new part file. Let me just make sure my settings are good for the recording. Cool. So if I make a new part file, our units are in inches. So let's make sure we apply inches rather than the metric system. Again, I like a plain white background. I should find a way to keep this as my default. I'll look into that later. For this one, it's a simple part to make, right? We have one sketch, one extrusion for the base of it, and then we have a hole. So we should do a sketch on this front view. I believe it's already in the front view. Sketch on the front plane. And this is what we need to sketch. So I will select the center of this circle as my origin. So I can see there I have a circle. Add a dimension. So the dimension here is a radius of 1.975. Now it's asking for my diameter, so I can do 1.975 times 2. So there's that, 1.975. I also have a second of, this one is radius 1.475. Again, times 2 for the diameter. All right, so those are those two. I know from the, let's say, right quadrant, I have a vertical line. Now this line has a dimension of 1.625. Right, yep, 1.625. I have an interior line. So from the right quadrant of the interior circle, again, it's a vertical line. And that one has a dimension of, if the total is 1.625 and we subtract 0.6, that would leave us this remaining distance. So for that, we should input, and again, if you don't want to do math, which in this case, it might be very simple, but if you don't want to, 1.625 minus 0.6, hit enter. There's that distance. Now let's see, we have, can we find this vertical distance? Sure, we could by doing some math. So if we have this radius, right, 1.475, that would be the distance of the center. So this point. Now, if that's 1.475, if we subtract this 0.975, again, that leaves us with our remaining distance. So we can go ahead and create a line from the end point. Oh, my computer's lagging there. So we create a horizontal line this time. And again, that one would be dimensioned as 1.475 minus 0.975. And continue this with another vertical line. Now this one has a dimension of, I'll clean these dimensions up in a second, 0.6. Okay, then finally I can connect these two lines together. Okay. Move these around a little bit. All right, so that's the shape that I need, which basically means I could trim. What I don't, let's refrain from trimming first. What I would want to do is let's create this on the other side. Now you can do that manually if you like, or the smart way to do it would be with a mirror. So let's find my sketch tools. I'm in my sketch tools. Let's find mirror entities. Well, what do I want to mirror? I want to mirror this line. I want to mirror this line, this, and this. This is what I want to mirror. Of course, I want to copy it so I don't delete the originals. And I want to find a plane where I can mirror this about. So if I hover over my different planes, in this case, it would be my right plane. I want to mirror these over my right plane, hit OK. Now we can trim. So let's find trim. Let's trim the power trim. I could trim that. I could trim here and there. Where you get everything from there and there. Okay, so if you trimmed it successfully, we should have that finished. Let's extrude this. So if we go to features, straight from our sketch, we'll go to features. I will extrude this the distance of 0.875. So we can do blind. We'll do backwards in this case of 0.875. Or you can do mid-plane, which is fine. I personally would prefer. That way we can keep some level of symmetry with our planes. Right? If I do this in a mid-plane, then that means that my front plane is still symmetrical to the part, right? Splits it down the middle, which maybe, not 100% required, but just to keep things kind of neat and organized. I see a mistake I made. I forgot this flat top. So as always, you can go back into your sketch. Let's go ahead and introduce that line. So see, it has a dimension of 0.35. I'm sorry, 3.5. So what I could do is I could make, let's say, a midpoint line, make sure I use the origin as a reference to make it vertical with that point. I don't know its distance. I don't know its size quite yet. So you can always just select something that works for you. And then I can dimension this line vertically, right? I could either dimension it as this original dimension is from the bottom of the part at 3.5, or I could dimension it from the origin if I do a little bit of math. But I'll keep it simple. Let's just dimension it off the bottom of the part. Let's see, I would over constrain. Okay. So this one should not change it because it's over constraining. Let me try. I want to try to maybe do the click on the bottom first and then the top. Might still be the same thing, which it is. Okay, let's cancel this. It's not useful to me. What can I do? So this has to be horizontal and vertical. Will it let me dimension it from the origin? Maybe not. Will you? Okay, it does in this case. So in this case, let's say we add the dimension from the origin. So it would just be a little bit different, right? Instead of 3.5, we would do the total distance 3.5 minus the 1.625. And, just to verify that that's correct, which it should be, what you could do is just quickly check now the dimension, which is 3.5, right? But again, I cannot create this without over constraining that. So finally, again, just trim. Now that that's in the correct spot, we trim all the unnecessary lines. Hit OK, try to back out. Cool. Now I have that added in, right? And what I need to do now to finish up this part is the cosmetic thread through this hole, which I don't currently have, but if we did a sketch on this face, I'll do a new sketch on that face, we can create our hole, right, by creating a circle about the origin. This one should have a dimension of 0.437 in diameter. So there's that hole. Go ahead and finish this with an extrude cut. Now it doesn't give us a distance, which is fine. However, what we could do is you can enter a blind distance that goes all the way through at some point. My recommendation for this one would be up to next. So regardless of where that next is, it'll cut all the way through. So up to next works fine in this. Now I just need my cosmetic threads, which let me go ahead and full screen this to type in, I believe there's an actual tool called cosmetic thread. Okay, now let me minimize this to put it back. All right, so this is my cosmetic thread tool. What it's asking for me here is the edge of the hole. So this is the edge of the hole that I want to thread. Standard for the standard units should be, let's try ANSI inch. Machine threads is fine. In this case, I have half by 13. Let me try to locate half by 13. It's not on here. It's only half by 20. Let's try a different standard, maybe ISO, which that's in metric standards. Let's find a standard that works for us. Maybe we could do none. No, that's not gonna work. That's also metric, more metric, more metric. Let's go through these. Don't think it's gonna be a straight pipe thread. Half dash 13. No, heated close is not it. Uh, I don't even know what that stands for. KS, JIS. Let me find a standard that works for us in this case, and I'll get back to you. Ah. So I went ahead and cheated and looked at these solutions, which show that this hole actually has a half by 20 thread. So this drawing needs to be updated, 'cause that's incorrect. So we're going to do a half by 20 in this case. Up to next again works fine. We're going to finish that cosmetic thread. As you can see, that cosmetic thread is applied. However, it's not showing up here. That's kind of the point of a cosmetic thread, just to signify that you have threads there. So I believe that's it for this component. Let's go ahead and save this. So downloads or somewhere that works for you. I will save it. Make a new folder because we have a few parts to make here. I think make a new folder. Call that folder problem 2 and save it in there. So this is called the V block clamp. V block clamp, file number 2. Go ahead and save your work there. Now you don't have to close this if you don't want, but my computer is running low on memory. So to help me, I'm gonna close that since we're done with it. Now let's make this part. So again, open up a new part file. Again, very simple component. One sketch, one extrusion. Sketches from the front view again. So for the sketch, I believe we already have a sketch on our front view, but just to verify, sketch on the front view again. I like the plain white background with no shadows. Cool. So let me zoom in here. Here's the sketch that I want to make. Again, I would select personally my origin to be in the middle. Up to you whether what you want to do there. So if my origin is in the middle, let's say I can start with these arcs. Do I know the distance? I'm sure I can find it somehow. Okay, it's gonna get a little complicated, but I could find that distance. So if I just make a circle, right, I want to make sure it's lined up vertically with the origin. Now this circle should have a dimension of what is my diameter? It should be somewhere. Center line, 6.4. Very interesting. I'm not provided any sort of radius. But I do know the angle of that line, so I could make that line out of fillet. Going forward, is that height doesn't matter. 29. I feel like you would need some sort of radius here, but I could be wrong. Let me look into that. Open. Mm. So again, I cheated. I looked at the solutions, and this one actually might be a little bit trickier than I had first thought. This isn't a good place to start. This is a good place to finish. So for now, we'll start on something else, but we'll get back to this. So let's not start on that circle. Maybe you can start on these vertical lines. So for this one, I'll use a midpoint line. So I know I have a midpoint line that is horizontal with the origin, right? So I can dimension it. The line itself is 0.625. And you know what I would like to do before that, because I know it's gonna happen. I would like to add a relationship, a geometric relationship between the origin and the midpoint of this line. Now I would like that to be horizontal, right? That way, when I change the dimension of this, this midpoint stays where it's at and it doesn't move around on me. So again, this is 0.625, which would help if I was in inches. Okay, good thing I caught that early. Make sure you're in the right units. So if we go back, not edit the sketch plane, but edit the sketch itself, and change this dimension to 0.625 of an inch. All right, and then it's also dimensioned. How far is this line from the origin? So it's 0.4 from the edge what's the total distance? 1.375. So I can add a dimension in between the line and the origin. To space it out right. So it should be 1.375 minus that 0.4. So now it's spaced out accordingly. Let's go ahead and continue with the horizontal line. Do we know that distance? Yes, we know it is 0.4. So this is 0.4. Let's go ahead and make a vertical line going down. Now I'm just adding the dimensions one at a time. 125. Let's see, we have here, we have another horizontal line. You got to be careful when you click. You see there, I thought I locked it into that endpoint, but I didn't. So this would be incorrect. Go ahead and cancel this. Yeah, that's not what I wanted to do. Delete this. Start a new line. Make sure you click on the right spot. And then now let's dimension this. I can't tell if my mouse battery is dying or if the Wi-Fi connection is slow, but I'm experiencing some lagging there, so bear with me. I might have to go a little bit slower. All right, now for this line, I have an angle. Actually, let me verify that this line is actually 0.4 because I just assumed that. It appears to be in line with this line, but let's verify, right? Let's check our dimension between the origin and the endpoint of that line, which should be 0.95, not 98. So this line is not actually in line here. So let's, before we do that, let's delete this dimension. And then let's add the dimension of 0.95, which would in fact change this distance. Very well. Okay, now we can add a line, right? Now this line, I don't know its length, but I do know its angle. So if I just come up with maybe some arbitrary length, and then I add the angle between this line and we're gonna need a line to reference. So what we could do, so we can make a reference line. I like to use midpoint line in this case. And make sure it's vertical. Distance isn't really important, but what is important is that this line is for construction, right? It's just for reference. It's not actually a part of our drawing. We just need it, in this case, to add a dimension. So this angle here should be 40 degrees. Very nice. And we need the same line in the opposite direction. So I think for now, what we could do is finish the right half of this drawing. I think from here, we could basically just mirror everything. So we've essentially made one quadrant. And in this case, we have symmetry in the X direction as well as in the Y. So we can just mirror both times for that. For example, let's say in this case, we want to mirror this line, this one, and this one over the X direction. So we're going to mirror about. Let's find the proper plane for that. So over the top plane in this case. All right. Now, what we should do is mirror all of this over the Y direction now. So for mirror again, this time I just want to quickly select everything. So you can use your selection tools for that. Let's see, what line is this? I'm going to deselect that. The reference line is not really too important to the drawing, so I don't need another version of it, especially if it's going to be in the same location it's at now. We want to mirror this over the Y. So in this case, the appropriate plane would be the right plane. Yes, we want to be a copy, finish that, and then go back in here. just to clean this up a little bit, maybe trim these pieces. Oops. I didn't mean to trim my reference line. So what I can do there is just extend it back into itself. We're one piece now. Sweet. We're one piece. What do we need to do now? Now we need to finish the arcs. So the way I would do this is it's not the radius or diameter is not explicitly given to us, but we can create a circle in this case on the reference line. Now, again, I don't know exactly its radius or diameter, but I do know that circle is dimensioned. I actually did this backwards. You don't start with the circle first. We could do, let's say, a point. We don't get to use the point too often, but we need a point, right? So somewhere along this line, there's a point. And that point has a dimension of 0.7 from the bottom of the component. So this dimension here should be 0.7. Now we need this point so we can add the, so we can use this as the center for our circle. So now that we have our point there, we want to make sure I lock onto that point. Now this circle, from this point, make it tangent with one of the lines that we created. Doesn't matter which one. Since it's in the middle, it should be tangent to both at the same time. All right, so, this is the radius that we need, but again, it's not given to us. So from here, it's pretty simple, right? We just trim what we don't need. In this case, these two pieces. And then we have our arc. Now you could do that to the opposite side. Again, use your tools. So a mirror would help us out in this case. And we want to mirror this arc about what plane exactly, I'm not sure, but we can hover over them to find out. Over the top plane in this case. There you go. As always, trim. And there it is. So that would be our final sketch. All we have to do now is simply extrude in one direction, or again, I like to just keep it neat. Do it mid-plane in this case. Total distance is 4 inches. Go ahead and finish that. So that's the finished component. Save this as a VBlock base in that same folder. So if I go to the folder that I made, could even click on this since it shares the name, sort of, VBlock base. So that was the second part of this assembly. Now we just have one more, which is the VBlock screw. So let me, again, I don't currently need this open, so let me just save this to spare my memory. Make a block, I'm sorry, of part. Plain white, as always. This one, let's see. This one to me would work two ways. I could revolve, right? If I sketched out the cross section and revolved it. Or in this case, I could do a simple extrusion for the screw section, the head section, and then, it's interesting. Let's go, I don't know. Let's go with the extrude one. Can't decide which. So in this case, so this is my front, maybe this is my top view. So let me sketch on my top. Let me do a new sketch specifically on my top view. So what I would be sketching is, let's say, the outermost circle and the one for the hole, right? So I have two circles. And before I even do that, make sure you're in the right units. That would help out a little bit. Again, sketch, top plane, circle. I'm going to use the origin as my center point. This one should be dimensioned as My outermost circle is 1 inch in diameter. That's good. Let me do my second, which should be, it appears to be 0.5. Very well. That's it. Now we need to extrude this. In this case, I wouldn't do a mid-plane. I would have to do a blind extrusion. My first extrusion, let's say I wanted to do just the head of the screw. So I do the whole contour, right? Not just to a certain region, the whole thing. The distance would be 0.75. I'll go ahead and finish that. And then also I need a separate extrusion. And again, you could always extrude based off the same sketch. So if I find that sketch that I'm referring to, in this case, sketch 3, this time I don't want to extrude the whole thing, right? I just want to extrude the center portion. Select that specific contour. The total distance is 4. It's actually, I want to flip the direction of this just to make it go down rather than up, which I can do. Okay. You don't always have to do this. I like to be neat with my work. This comes more into play whenever you get into more complicated drawings or more complicated assemblies. But you could rename your features, right? Like in this case, I know this feature pertains to the head of the screw. So I can call this screw head. In this case, this specific feature pertains to the shaft of the screw. So I can call this screw shaft. Just all neat and organized in that way. You know, if you have a bunch of extrusions that are, listed off as extrusion 1, extrusion 2, extrusion 3, this is more clear and concise as to what feature pertains to what. What do I need? I need some chamfers, right? I have 3 chamfers given a distance and an angle. So if I find my chamfer tool, what do I want to chamfer? I want to chamfer this edge, I want to chamfer this edge, and at the bottom edge as well. Now I have a distance angle chamfer, which is my default, which is great. So I have a distance of 0.75, 0.075, and an angle of 45 degrees. Hit OK. There are my chamfers. Great. Let's make this hole on the side here. So if I go to sketch, I'm going to do a new sketch, find a good plane for that. I'm going to call that my right plane in this case. I need a circle for my hole. Now it's dimensioned as 0.375 from the edge. So I can just make sure I make that vertical for now. I would believe you can also reference the center of the bolt head. So again, this one should have a dimension of 0.375 from the edge. Diameter would be 0.25. Now just to double check, what is the dimension between this and the edge? Should be 0.375, which it is. Now it's just rounding it. But if I do it there, 0.375, perfect. Let's see, features, extrude cut. In this case, again, up to next works perfectly fine in this case. Ooh, but I do need to do a mid-plane right since I sketched it on my right plane specifically. This would have to be a mid-plane. Or I can do through all both, right? If I don't want to enter a specific distance for the mid-plane, through all both would do what I need it to do. So now I have a nice clean hole through the part. Let's see, is that threaded at all? Nope, that is it. So let me save this as a V-block screw. Save that. Okay, again, I'll need this at the moment so I can close it, save on some memory there. And let's go back to our assembly file. Um, Microphone. All right, so I switched over to my computer audio because my AirPods died, so hopefully it doesn't sound too bad. But if we continue this part, right, we need to make an assembly file. We need to insert our components. The first component I would start with is the what is the base, right? Because that one should be fixed. So I would start with the base. So I'm just going to insert that first. And then follow that up with the clamp and the screw. So I'll have the clamp now. And I also have a screw. So there's that screw. So first things first, right? Our base is fixed. That's good. This is still, our clamp can move around. Let's add a mate. What should we mate? This clamp, I'm sorry, this edge should be mated with, oh no, that's not the edge, not the edge. Um, you see this face should be mated with this face. So that's one. So now those faces are mated together. You know what? I'm going to do something a little bit different. I'm going to introduce an advanced mate. Right. So one thing that I know is that this clamp theoretically should be split down the middle when it's applied to the base, right? Meaning if I do a with mate, all right, so I want to make sure it's equally spaced. So these would be my first two selections. I want to make sure out of all these selections that I'm making, they're equally spaced in width. So now that width mate is going to make sure, you know, it's, and I'll show you what that looks like in this direction, right? So those two faces were mated up to each other, but I like the width mate better on this one. And we also need to do a width mate for, let's say, for example, this space. Oh, I can select that. Let me get, oh no, I can zoom in on the back here. So this distance needs to be separated by these two. Let's see. That's what that looks like in this case, right? And that's why I did a with me in this case, because if I mated these two faces together, then you would have had a larger gap here. So just, you know, to be a little bit more precise, and we're assuming this is there. So now we should have a proper articulation of the clamp in our base. But as you can see, the clamp is able to be removed. In this case, let's see, what is the problem? Let me read the problem statement for this. So create 3 parts and assemble the parts in the following spaces. After completion, the screw on the top should be able to screw in and out of the hole screw mate. Also, the clamp should not be able to move back and should be able to move back and forth along the groove, but not fall out of the base. So in this case, we just want to make sure that this doesn't happen, right? It's just going too far out. You know, in real life, the screw itself would be what's holding the clamp onto the base. But in this case, just to show you guys some more mates, we want to make sure we constrain this to not be able to move past the clamp itself without the screw. So the way you would do that is we need to do some sort of limit mate. I would believe it's a distance mate, you know, because we have distance mates, we have angle mates. So for your limit mates, you need to go to the advanced section. So I want to find a advanced limit for the distance. What do we want to limit exactly? I would say in this case, you could limit, let's see, let me find a plane. Oh, that's why I need a plane for my V block. So my front plane in this case, and my base. So these two need a limit mate. Already have. Let me save this just in case it crashes. So I'm gonna do no. Close this. Let me save my work. Yes, rebuild it. I'm gonna save this in the folder where I have problem 2 stuff. So this would be, what should I name this? V block assembly. Okay, V block assembly. And just save that. Okay.